Now for our next example in 2.6, we're going to look at example 4 right here. This is a similar example to the previous one where we're going to need to work on making a compatible multiplier. So we're still going to be using this trick of multiplying by this reciprocal of the highest power of x in the denominator, but got to be a little bit careful where there's roots, radicals involved. Okay, so we've got an interesting limit here. The limit as x approaches negative infinity. Don't think any of our examples so far have had negative infinity, but we're basically going to treat it exactly the same way as we have been. Okay, so x is approaching negative infinity, and our function is the cube root of x to the 6th plus 8 over 4x squared plus the square root of 3x to the 4th plus 1. All right, this is a handful. Okay. And the first thing we've got to do is determine the highest power of x in the denominator. Now this one is a little trickier than the previous because this is not just a standard polynomial down in the denominator here. So we do see that we have a power of x squared in this first term, 4x squared. But then you might see this 3x to the 4th under the square root and think, well, wouldn't x to the 4th be the highest power of x in the denominator? And not quite, really. Although it does say x to the 4th there, you gotta know or notice that it is underneath a square root. So effectively, it's kind of like a square root of x to the 4th situation that we're looking at. So let's write this. Square root of x to the 4th. Effectively, this is like x squared. All right, so if you see a higher looking power, but it's underneath a root, you've got to take that root into account. Okay, so this is effectively like an x squared, which means the highest real power of x in the denominator is going to be x squared. So highest x squared, and the reciprocal of that, of course, would be 1 over x squared. So that's our multiplier, 1 over x squared, 1 over x squared, numerator and denominator. Okay, and let's go ahead and write everything in a single fraction here, or a single rational expression. Put our 1 over x squared up in the numerator with that cube root, x to the 6th plus 8. Okay, and then when we distribute down in the denominator, the first term will turn out nicely. 4x squared times 1 over x squared would just give us a 4. And then plus, when we distribute next to that radical, we're going to end up with a situation like we just saw in example 3. The 1 over x squared is not under a square root, so it can't really get into that radical there. So 1 over x squared times the square root of 3x to the 4th plus 1. Okay. Now we are going to have to make that multiplier, the 1 over x squared, compatible with the roots that it's next to. So here, this, let's start down in the denominator with the 1 over x squared. That is next to a square root. So you want your multiplier to map the type of root that it's next to. So that one we need to write as a square root, just like we did in example 3. Okay, so here, write as a square root. Okay, so the 1 on top, not a problem. Square root of 1 is 1. Well, here I'll write our 1 over x squared first. So square root of 1. And then you got to think, okay, what is x squared the square root of? Well, if you want to have a nice kind of fast trick for this, take whatever you're looking at, x squared in this case, and square it, and you'll know what to put underneath the square root. Okay, so x squared squared is x to the 4th, and so x to the 4th should go underneath our square root there. All right, the square root of x to the 4th is x squared. And so then we can write this as a square root of 1 over x to the 4th. And that's what we'll do. All right, now we do have another multiplier to look at in this problem. We've got the 1 over x squared up in the numerator, and notice that it is next to a cube root. So we're going to switch things up a little bit for that. All right, so this one we need to write as a cube root. Same idea. Okay, we'll take 1 over x squared. That 1 on the top is super nice because 1 is the cube root of 1. Okay, basically you're just going to keep that 1 on the top. All right, so we need to handle the denominator. X squared is the cube root of what? And we can use the same type of trick that we just did right down here to figure out a square root. What do you put underneath the square root? Well, take the original and square it. So in the case of a cube root, you can take your original x squared and cube it. Okay, so x squared to the 3rd, we would multiply those exponents. That would be x to the 6th, and that is exactly what should go underneath that cube root. Okay, the cube root of x to the 6th is x squared. So our overall cube root is going to be the cube root of 1 over x to the 6th. Okay, so that's going to be for this multiplier right there. All right, so let's write those in. Got the limit as x approaches negative infinity. And we'll have cube root of 1 over x to the 6th and the cube root of x to the 6th plus 8 in the numerator. And then 4 plus our square root of 1 over x squared times the square root of, 3 x to the 4th plus 1. Okay, so that means that now our multipliers are compatible with the radicals that they're next to. And so we'll have a limit as x approaches negative infinity. Got to keep writing it. Yes, it's tedious, I know, but we need to make sure our notation is good. Let's do this multiplying underneath our cube root. Write it all together, and then we'll have the same type of thing in the denominator. Put those terms underneath a square root. Oops. Oh, hey, you guys might have noticed I made a little typo here. When I rewriting our 1 over x squared in the denominator, I forgot to do 1 over x to the 4th underneath the radical. So let me go in and fix that. Okay, and whoops, got rid of a little more than I wanted to there. 1 over x to the 4th. There we go. Because you know how I spotted that was the fact that we have 3x to the 4th underneath our radical. Usually you should end up seeing that same power in your multiplier. So 1 over x to the 4th. There we go. Now we can do our distribution and things are going to turn out nicer that way. Okay. So that frequently happens, not 100% of the time. I did have a little advantage because I know where this example is going. But yeah, often you'll end up seeing that same power show up. Okay, now that that's fixed, let's go ahead and distribute things. Hopefully I can fit this example in on this page. And we'll have our cube root of 1 plus 8 over x to the 6th. I'm going to write it a little bit sideways there so I can make things fit. And then in our denominator, we have 4 plus, and distribute here. That would be the square root of 3 plus 1 over x to the 4th. Okay. So yeah, that was just distributing underneath the radicals, and you start to see those familiar expressions pop up, the expressions that are going to approach 0 as x gets very, very large. Now, remember that that also works for x getting very, very large in the negative direction. That's still part of our useful theorem and its extension, okay? Remember, this works with x going to negative infinity. The extension still works with x going to negative infinity. So essentially, it's the same type of thing going on here. 8 over x to the 6th is going to approach 0, and 1 over x to the 4th is going to approach 0. So we let them. And we get the cube root of 1 plus 0 over 4 plus the square root of 3 plus 0. There we go. And so then if you simplify that, cube root of 1 is 1 over 4 plus the square root of 3. All right. And I managed to fit it in, yay. Okay, so that is our answer. You could also rationalize this since it does have a radical down in the denominator. I don't personally mind if you leave it in this form, that's all right. Rationalized, it turns out to be 4 minus the square root of 3 all over 13. If you want to practice your rationalization, but this is okay. So we'll leave it at that.